Welcome to Tell Me More Stories Told as podcast.
Great to be here.
Today we're doing something a bit different. We're tackling an object you probably use dozens of times a day without even thinking about it.
The humble hinge.
Exactly, the hinge. Seems simple, but oh boy, is there a story there.
There really is. We've pulled together quite a bit of information. And honestly, the history and the sheer variety is fascinating. It's not just about swinging doors.
No, definitely not. So our mission for this deep dive is to really unpack that story. We'll trace it way back, look at all the different kinds. Seriously, there are loads, and find out where they pop up in really unexpected, even massive ways.
Prepare to have your perspective shifted, I think. It's more than just metal bits.
I'm ready. I've already had a few aha moments myself just looking through the material. So where do we start? Ancient times.
Let's do it. Back to the very beginning.
Yeah.
Because hinges aren't, a recent thing. They've been fundamental for, millennia.
Millennia for hinges. Wow.
Yeah, seriously. We actually have archaeological evidence. Remains of hinges made from stone, marble, wood, even bronze.
Stone hinges. That's
Yeah.
hard to picture.
I know. But they found them. And some date back at least to ancient Egypt. Think about the pyramids, the temples. They needed ways to open and close things, even back then.
It really grounds the invention, doesn't it? It makes it feel even more fundamental.
It does. And in ancient Rome, things get even more interesting, linguistically at least.
Oh,
Their word for hinge was cardo. C-A-R-D-O.
cardo.
But cardo wasn't just the hinge itself. It was like a bigger concept.
How so?
Well, first off, there was a goddess named Cardia.
Named after a hinge.
Sort of. She was the goddess of thresholds, doorways, pivots, basically all the things a hinge relates to.
That's wild. So the hinge was important enough to have a goddess associated with it.
It seems so, and it goes further. The main north-south street in a Roman city,
Yeah.
also called the Cardo Maximus, the central axis the city turned on.
Whoa. Okay. So the hinge, the cardo, was literally the central point, the pivot in their minds.
Exactly. It's amazing how a simple mechanism could carry that much symbolic weight. And even today, that Latin root lives on.
It does. How?
Think about the word cardinal, like a cardinal rule or a cardinal direction.
Oh, right. Meaning fundamental, principle.
Precisely.
Okay.
It comes from cardo, meaning the chief thing on which something turns or depends. All from the humble hinge.
That is genuinely fascinating. I'll never look at the word cardinal the same way again. What about the English word hinge? Any story there?
A simpler one, but yeah, it's related to the word hang.
Ah, that makes sense. It lets something hang but still move.
You got it. Which brings us nicely to how most hinges actually work, the core principle.
Okay, the mechanic.
Most hinges operate on what's called the barrel
The
principle.
barrel principle.
Yeah, think of a barrel just as a hollow cylinder, simple shape.
Okay.
So a barrel hinge has a sectional barrel, basically, interlocking hollow parts. This part is often called the knuckle,
The knuckle, like a joint.
exactly like a joint. And through that knuckle, holding it all together, goes a pivot pin.
Got it. Knuckle pin allows rotation.
That's the essence of it. And this leads us to probably the most common type you see everywhere, the butt hinge.
The butt hinge. Right. One's on most doors and houses.
Yep, also called a mortise hinge,
Mortise. Why mortise?
because it's designed to be set into a mortise, a recess or groove, cut into the door frame and often the door itself.
Ah, so it sits flush. That makes sense. That's why they look so neat.
Exactly, gives it that clean look. Sometimes, though, you might see a half mortise hinge.
Meaning?
Only one leaf, one side of the hinge, is recessed or mortised in. The other sits on the surface.
Okay. But fundamentally, these butt hinges, these mortise hinges, they're mostly barrel hinges.
Overwhelmingly, yes.
Yeah.
They have those leaves, the flat parts, connected by the knuckles with the pin running through the middle. That's the barrel principle in action.
So we've got the ancient history, the cool Roman connection, and the basic mechanics of the butt hinge. But you said there was a huge variety.
Oh, yeah. We've barely scratched the surface.
Yeah.
Beyond the standard butt hinge, there's this whole world of specialized designs. Some are purely functional. Some add a bit of, flair.
Flair on a hinge?
Definitely. Think about butterfly hinges.
Butterfly.
Yeah, the leaves, the flat parts, are shaped like butterfly wings. They look quite decorative. In the UK, they sometimes call them parliament hinges.
Huh. Okay, I can picture that. Decorative. What else?
Well, there are case hinges. Similar idea to a butt hinge, but often a bit more ornate. You find them on, like, nice suitcases, briefcases, that kind of thing.
Yeah, right. Gives it a quality feel. Okay, what about the ones you don't see, like on kitchen cabinets? They just seem to disappear.
Magic hinges. Those are concealed hinges, often
Yeah.
called cup hinges or Euro hinges.
Euro hinges.
Yeah, because the design originated in Europe, and they often use metric measurements. They fit into a cup-shaped recess drilled into the door.
And they're adjustable, right? That's the brilliant part.
Totally. You can tweak them in place to get the doors perfectly aligned. No more wonky cabinet doors.
A lifesaver for DIY projects. Okay, another one. Piano hinges. The name sounds obvious.
It is pretty descriptive. Also called continuous hinges. They run the entire length of whatever they're attached to.
Like a piano lid, presumably.
Exactly. Or a big toy box lid, maybe some types of industrial doors. Gives really strong continuous support.
Makes sense. What about flag hinges?
Simple, clever design. Basically two separate parts. A pin on one leaf and a socket on the other.
So you can just lift the door off.
Precisely. Makes removal super easy. They come in left and right-hand versions, obviously.
Handy. Then there are H hinges and HL hinges, named after the letters.
Yep, their shapes resemble the letters H and L. You see these a lot in older houses, historically used for passage doors, closet doors. They have a certain period charm.
It's like architectural history embedded in the hardware. What about pivot hinges? They sound different.
They operate a bit differently, yeah. Instead of being on the edge, the pivot points are in the floor and the top of the door frame.
So the door swings on points, top and bottom.
Kind of, yeah. It's an older, sometimes lower-cost method. You find it in very old buildings sometimes. Doors using them are called hair-hung doors.
Hung. Interesting name. Wow, the list keeps going. Self-closing hinges.
Modern convenience. They have a spring mechanism, often with some kind of damping or speed control, so the door closes gently behind you. No slams.
Nice. And spring hinges, are they the same?
Similar, but spring hinges use a spring that can help either close or open the door, depending on the design. They provide some assistance.
Okay. And you mentioned accessibility.
Right. Swing clear hinges, also called offset hinges. The design allows the door to swing completely out of the door frame opening.
Why is that important?
For accessibility, it provides the maximum clear width for passage, which is often needed for wheelchairs or medical equipment, meeting standards like the ADA in the U.S.
That's really thoughtful engineering. Now, living hinges, that sounds organic.
It kind of is. It's usually a thin, flexible piece of plastic molded as a single unit with the parts it connects.
So no pin, no knuckles, just bendy plastic.
Exactly. Think of the lid on a plastic storage box or a Tic Tac container. That flexible bit is the hinge.
Wow. Okay. Obvious advantages. Rust-proof, quiet.
For sure. But maybe not as strong or durable for heavy-duty applications. They can break more easily over time with repeated flexing.
Makes sense. Good for lightweight stuff.
Yeah.
And the list, it just keeps going. Coach, counterflap, cranked.
Double action, flush, friction, lift off, pinge, which has a quick release pin, rising butt, steering hinges, key hinges. Yeah, it's a huge variety.
It really shows how this basic idea of a pivot has been adapted and refined for almost any situation you can imagine.
Absolutely. Every type is basically a solution to a specific movement challenge. Middle of the podcast.
Okay, quick pause here. If you're finding this deep dive into hinges as surprisingly fascinating as we are, and you want more stories about the hidden world of everyday objects, definitely hit that subscribe button.
Yeah. Don't miss out on future explorations here on Tell Me More Stories Told as podcast. We find some pretty interesting stuff to talk about.
Okay, back to hinges. We usually think doors, cabinets, maybe toolboxes, but they show up in much bigger things, right?
Oh, absolutely.
Yeah.
Their role goes way beyond the household scale. Think about history first.
Okay.
Castles, drawbridges,
Of course. Massive hinges needed there.
huge ones. Since medieval times, the security of a fortress often depended on those giant hinges working reliably. Talk about high stakes.
Literally life and death hinges. Okay, moving to modern times. Architecture.
Yep. Sometimes buildings are designed expecting some movement, some settling, especially if they're built on less stable ground.
Right.
There's a great example. The Dakin Building in California, Brisbane, California.
Oh, what's special about it?
It was built on piles over bay mud, which is, soft and prone to settling.
Okay, tricky foundation.
Very. So the engineers did something clever with the entrance ramp. They built it on a massive hinge.
A hinge for an entrance ramp.
Yeah, a really big one. It allowed the ramp to accommodate the settling of the main building without cracking or breaking. It apparently worked for years.
That is ingenious.
Yeah.
Using a hinge to basically decouple the ramp from the building's movement.
Exactly. A simple principle applied to a complex problem. But it gets even bigger.
Bigger than buildings.
Think infrastructure, elevated freeways, railroad viaducts.
Hinges and freeways. How? Why?
They're built into the structure at certain points. Their job is to manage stresses. specifically bending stresses.
Okay. How does that work?
Imagine a long bridge or viaduct. Temperature changes, loads, even earthquakes cause movement and stress. If it were one solid, rigid structure, those stresses could build up and cause catastrophic failure.
Right.
The hinges act like joints. They allow controlled movement between sections, reducing the transfer of that bending stress. It makes the structure more flexible and resilient, especially against earthquakes.
So they're like deliberate weak points, but in a controlled, safe way?
Not weak points, exactly, more like points of controlled articulation. They allow movement where it's needed to prevent stress buildup elsewhere. Sometimes they're called zero-moment hinges,
Zero moment, meaning
meaning they're designed so that absolutely no bending force, no moment, is transferred across that hinge point. It purely allows rotation or slight shifts.
that's incredible engineering. From drawbridges to earthquake-proofing freeways. What about up, outer space?
Even there, hinges are absolutely critical in spacecraft.
No way. How?
Think about solar panels, antennas, other equipment. They have to be folded up tightly for launch, right?
Yeah, inside the rocket fairing.
Then, once in space, they need to deploy. That deployment relies on specialized hinges.
Yeah.
Self-actuating, self-locking hinges.
Self-actuating, they open on their own.
Often triggered by a small pyrotechnic charge or a spring mechanism, yes.
Yeah.
And they have to lock rigidly in place once deployed under extreme temperature variations and radiation. It's a huge challenge.
Wow. So the success of a multi-million-dollar satellite can literally hinge on a hinge working correctly in space.
Pretty much. It's amazing. Ancient Egypt to Mars rovers. The principle endures.
Okay, speaking of massive structures, that fun fact about the Sydney Harbor Bridge.
Ah, yes. That's a great one. That huge steel arch bridge actually incorporates hinges.
Seriously, where? You can't see them, can you?
They're built into the structure, particularly where the arch meets the pylons, I believe. They were crucial during construction, but they still serve a purpose.
Which is, it's not settling, is it?
No, it's thermal expansion and contraction.
Ah, the steel expanding in the heat and shrinking in the cold.
Exactly. Imagine the sheer size of that bridge. The amount of expansion and contraction over a year is significant. The hinges allow the massive steel structure to breathe with temperature changes without building up damaging internal stresses.
So even that giant, iconic landmark depends on the same basic principle as my garden gate hinge. That's fantastic.
It really puts it in perspective, doesn't it?
It really does. Okay, to truly sound like we know what we're talking about, maybe we should cover some key hinge terminology.
Good idea. Knowing the parts helps understand the differences. Let's start simple. The pin.
Right, the rod down the middle, the axis, sometimes called a pintle, I saw.
Yep, pintle is another term. It holds the leaves together within the knuckle.
Knuckle, that's the hollow cylindrical part the pin goes through, right? Also called a loop, joint, node, or curl.
All those names refer to that interlocking part, yes. And the leaves are the flat plates that attach to the door and the frame, the bits that actually move around the pin.
Got it. Pin, knuckle, leaves. What's end play?
That's the amount of axial movement possible between the leaves, like along the pin's length. A little bit is usually needed so it doesn't bind up.
Okay, a bit of wiggle room.
And gauge.
Simple one, just the thickness of the metal the leaves are made from. Thicker gauge generally means stronger hinge.
Right, then hinge width. Is that how long it is?
No, that's hinge length. Hinge width, or open width, is the measurement across both leaves when the hinge is fully open, like flat on a table, measured side to side, perpendicular to the pin. Okay, width across the open leaves. Hinge length is the length parallel to the pin. Got it.
And knuckle length is just the length of one individual knuckle segment. Finally, leaf width is the distance from the center of the pin out to the edge of one leaf.
Wow, okay. A whole vocabulary just for hinges. But it makes sense if you need to specify exactly the right one.
It does. And knowing those terms helps understand some of the even more specialized types we haven't mentioned yet.
There are more.
Oh, yes. For example, butler tray hinges.
Butler tray. For what?
For those old-style tables where the top is a removable tray or the sides fold up to become a tray, these hinges fold to 90 degrees, but also snap completely flat.
Clever. Okay, what else?
Card table hinges. Specifically for antique card tables where the top folds over on itself. They're mortised in.
Specialized indeed. Carpentaides joints, that sounds fancy.
They look quite elegant, made of several thin, curved metal strips acted together as a hinge.
Huh. Different. Drop leaf table hinges.
Used with rule joints, typically. They mount underneath the table and allow the leaves to drop down smoothly.
Right, classic design. Hinged expansion joints. Back to construction.
Yep, allowing bending in just one plane, often used in pipelines or ductwork, sometimes bridges too.
Well, you mentioned handcuffs.
Yeah, some modern handcuffs use hinges instead of chains between the cuffs. It restricts movement even more.
A slightly grim application. And biology. Antibodies.
It's amazing, isn't it? Part of the antibody molecule structure is called the hinge region. It provides flexibility, allowing the antibody parts to bind effectively. Shows how fundamental the hinge concept is.
From molecules to drawbridges, that's some range. And that other name for piano hinges.
Ah, yeah. Originally, they were sometimes called coffin hinges
Coffin hinges. Wow.
because one of their early common uses was, well, on coffin lids. Long, continuous support needed there too, I suppose.
A bit morbid, but fascinating history.
It really is.
So if someone gets really into this, there are even tools, hinge benders.
Yep, for tweaking or adjusting hinges. And concealed hinge jigs for accurately drilling the holes for Euro hinges.
And concepts like floating hinges, geared continuous hinges.
Right. Floating hinges allow a bit of linear movement as well as rotation. Geared continuous hinges are super heavy-duty versions of piano hinges, often using gears instead of a simple pin for very high-traffic doors. The world of hinges is deep. Outro.
Well, I think it's safe to say my perspective on hinges has definitely been broadened. The next time I open the fridge or walk through a doorway, I'll probably pause for a second.
It's hard not to once you know the history and the variety. They seem so simple, but they represent millennia of refinement and adaptation.
From stone pivots in ancient Egypt to those complex locking hinges on spacecraft, it's quite a journey.
And think about that Roman goddess, Cardia, protector of thresholds. Her name linked to Cardo, the hinge. It underscores how central, how pivotal this invention really was, even symbolically.
Or the engineers using hinges to let massive bridges expand or protect buildings from earthquakes. Just incredible ingenuity based on a simple concept. So here's a final thought to leave everyone with. We've seen how a basic pivot underpins so much. What other simple, seemingly mundane elements are out there, quietly enabling complex technologies or huge structures? What other hinges are hiding in plain sight?
That's a great question. Maybe something for people to ponder.
Definitely something to think about. Thank you for joining us on this surprisingly fascinating journey into the world of hinges.
My pleasure.
This has been Tell Me More Stories Told as podcast. Until our next deep dive, keep looking closer at the world around you. Keep those curious minds turning.